Good morning, Renee. This is Aslı. So I had your questions last night, but it was quite late, so I'm trying to answer them right now in this recording. And also, I wasn't sure that which question or questions you were not comfortable with. So as far as I understood from your screenshots, I will try to address for question 3, 4, and 5, I have put similar questions that has been asked in that quiz. So in question 3, the question was different. I tried, as I said, I formed a different question with the similar type. So with this question, what we need to first understand this ln. What does this ln represent? That ln represents logarithm e. So we don't write it. Logarithm base e is ln. So then we're going to rewrite that black statement. Here is ln e t minus 3 equals 5. And we can convert it easily by using the exponential rules. E to the 5 will be equal t minus 3. Yep, so that will be the final answer. All right, easy peasy. The only trick is we should be able to identify logarithm e is equal to ln. Just make that change. Also, there's another thing, maybe it begs to mention, log means log base 10. Okay, so if you don't write any base underneath this log, so it means that base 10. Otherwise, we identify the bases specifically, like log base 5 or log base 3. All right, hope you feel better now with this type of questions. Now, question 4. It says, write the third degree polynomial in its roots form. Remember, in its roots form, in its linear form. Okay, so I need to have the first degrees, or you can say that the factored form. All right, so how are we going to do that? First, identify the roots. One of the roots is here, -1. The other root is here, 2. So if I have -1 as a root, I need to write it as x plus 1. If I have as a root 2, I can write it as x minus 2. Because when x plus 1 equals to 0, that will be one root. And this is equal to 0. This will be other root. So these guys will be multiply a coefficient a, and this will be equal to my polynomial. However, we need to look at some multiplicities there. Because at 1, function just touches, so this root will have a multiplicity of 2. Because at 2, the function cuts across the x-axis, so this root will have a multiplicity of 1. And as you see, referred from the question, now we have third degree. So now we are talking about a function like this. We don't write the exponent 1. So now our next job is to figure out what that a is. For that a, I will be using this point 2. So that point is actually 0, 2. Now I'm going to plug in 0 for x's, keep a, 0 plus 1 square, 0 minus 2, and f of 0 is equal to 2. So I'm going to replace it with 2. Then write down 0 plus 1 is 1, 1 squared, 1 is a, 0 minus 2. So I'm going to have 1 from here, -2, -2a. So then I need to solve for a here. Then I will end up with a is equal to -1. Okay, so what will be our polynomial? Our polynomial will be f of x equal to -1 x plus 1 squared times x minus 2. Ta-da! I hope it helps you to see it better now. All right, so the other question, question 5. This is about solving quadratic inequalities. I'm writing it here because there are PowerPoints content folders, so you might want to go back and look at a couple of more examples if you want to. So when we're solving inequalities, one thing is important, we need to be seeing 0 here. So let's rewrite that inequality. X squared plus x minus 42. Okay, so that's the first thing we need to do, rewrite. Then factor or find the zeros. All right, so then when we factor x squared plus x minus 42, we are going to have 7 and negative 6, right? We can factor it that way. Then we find the roots. Okay, now sign chart. That's the other thing. So rewrite, factor, or find the zeros, then sign chart. So sign chart of these roots. So how are we going to do that? So negative 7 and 6. Negative 7 is a root for x plus 7. Right? 6 is a root for x minus 6. All right. So the reason I'm placing the zeros there is a placeholder to make sure that which number is a root for which linear component. So then I'm giving testing values. So for this equation, for x plus 7, if I give the values less than negative 7 here, which is negative 8, negative 9, negative 10, this linear figure will be negative there. And then if it is negative here, that will be opposite, positive. Because there's no root for here, x plus 7, it's going to continue like that. So I will be doing the same thought process for x minus 6. So x minus 6, if I give number less than 6, like 5, 4, 3, 0, negative 1, this will be negative here. And it will continue negative because there is no roots for x minus 6 here, and it will be right opposite there. Now, I need to think that I'm multiplying them because it's a multiplication of these two roots. It's giving me this quadratic. So negative times negative, it's positive. Positive negative is negative. Positive positive is positive. Okay, so we're good. Now, what we were wanting, now we need to go back. Okay, we're wanting this quadratic term less than or equal to 0. So then this is our solution area. So what is that happening here? So we're coming from negative infinity till negative 7, and here we're coming from negative infinity to negative 7. And here we're between negative 7 and 6, and from there on we're going from 6 to positive infinity. This is what each interval represents. However, our solution lies between negative 7 and 6. And why did I put this equal signs? Because we're wanting is less than or equal to 0. So this is an inequality way of showing it. So I believe we're asking the interval way of showing it. So then we're gonna write negative 7 to 6 equal. So this will be the solution. All right. So hope it helps. If you have any questions, let me know again. I'll do my best. Okay. See you.